end up in a low Earth curve, be for a little while, and then come back down. But what happened is the stages failed to separate, and the rocket had 33 engines on the bottom that would help this separation take place, and a bunch of them didn't fire. And without that separation, it began to tumble because the rockets were not all firing in the same direction, like a bad wind on a sail, and it started to tumble. And then the rocket apparently disassembled unexpectedly.
Which is what we all witnessed as that happened.
Yeah.
Too. So just some things along the process. Which obviously this is a very complex rocket. From what I understand, this is the largest rocket launch of all time. Do I have that correct?
Yes, it's actually the NASA SLS, Space Launch Systems, is a really large rocket too, but the SpaceX Starliner is about 9 or 10 meters taller and has some bigger engines and stuff going on here. And it's also, interesting enough for its size, a little lighter. And it's also a reusable rocket. It's supposed to go up and then be able to, the stages will come back down and launch and land on the launch pad again. And so it can be reused, where the SLS is a one and done type of rocket system from NASA.
Which there's a lot of advantages, right, for that, for it being reusable. I mean, obvious advantages as far as cost-wise, but are there
Yes,
other?
very much so with cost. But you do have to check them very carefully to make sure there hasn't been any damage or any leaks between uses.
So with something of this magnitude that's obviously taken years and years to get up to, how does this happen that that they miss something like this?
Well, this launch has been delayed 2 or 3 times. They had pressure problems in the last week or so with some valves, and you don't know. NASA had some serious accidents back, 20, 30 years ago as well, and it would be something as simple as temperature, air temperature. And you never know, a little leak, something happens, a valve doesn't release, a fitting doesn't work properly, and the rocket disassembles.
Yeah, it's quite spectacularly, as we were seeing. I'll go ahead and have that playing there again too. So, from this step, obviously this didn't work. I'm assuming everything there is a total loss. What do they do now? Like, what is the next step in the process for Starship?
Well, they will go back. I mean, they'll already have another uh, rocket in process being built. They will analyze all this data, find out what the problems were, and try to correct those immediately, and then schedule another test launch. They want to use this rocket to deliver astronauts potentially at Artemis 3. Artemis 1 mission to the moon will be a NASA SLS launch rocket. Will circle the moon and come back. Artemis 2 mission will be the SLS NASA rocket actually delivering astronauts to the surface of the moon. And Artemis 3 was supposed to be the use of this Starship by SpaceX. So to keep on track for the next handful of years, they will have to get this corrected and be safe enough so that NASA will say, yeah, we're willing to put astronauts on this to send up in space. One of the things with this rocket that's interesting too is it's not a launch and then go straight to the moon. It would launch, go into orbit, and SpaceX would then make delivery of more fuel to the rocket while it's in orbit, and then it would then go on to the moon. So it's very much different than the SLS, which will launch, then go up, and then send the Orion capsule with the crew directly to the moon. So there are differences in the style of design and what the mission profiles are for both of these.
So, looking at those, kind of the contrast, and I think you kind of went into it a little bit there as far as the contrast between NASA and SpaceX. Can you kind of expand on that and what the different maybe philosophies are between these two? Because SpaceX is so, you see a lot of show. It's a lot of performance that goes along with it, a lot of cameras and everything. NASA doesn't seem to be quite that same. Is that an accurate interpretation?
I know that NASA, their way of doing things is highly designed equipment that is a safety first mission. I can't speak for Mr. Musk's philosophy, but I know they take an awful lot of risks, and that they like these things that, I mean, they don't want them to blow up, but when they blow up, they use that as a reason to continue to design and advance their um, purpose and their mission. And he wants to go to Mars, and so he's going to do everything he can to get a rocket that he will launch and do that. I do know that it's been NASA's philosophy in the last 10 years or so to say that they want independent companies to engage in low Earth orbit space launches, putting up satellites, doing those kind of things, taking food to the International Space Station. But NASA wants deep space exploration to be their purview. And now you have these independent companies that are also saying, well, we want to go to Mars. It brings up some problems with treaties that the United States has signed with other countries concerning deep space exploration and what you can do when you get to a location, about what you can exploit and not exploit, what you can do and what you can't do.
Really?
Yeah, there's a whole series of treaties starting back, I think the first one was 1962, about what you can do. You can't just go someplace and set up shop or start mining things. There's a whole new set of these coming out right now called the Artemis Accords that are trying to set rules for going to the moon. Like we want to go in the next couple of years to the south hemisphere of the moon, the South Pole. China's actively trying to go as well, and they're trying to set up the rules. So what it says what you can do and what you can't do,
Is
but
that
also to say if there's a problem that it's like at sea, you come and help someone if they're in danger. Want to have equipment that could be swapped out if something goes wrong. So they're trying to establish these new set of boundaries and also a set of collaborative frameworks for people going on these exploration missions?
so? It really is like kind of starting over in sort of maritime law, space law. And
Exactly.
I don't know if
Because
that's the right term. Space law sounds like a sci-fi show, but
you don't want it to be the Wild West or,
yeah.
Pirates at Sea type of a thing.
Well,
So,
let's talk about that, kind of going forward with the Starship program. We see this today. Obviously, eventually, you mentioned going to Mars, and that is kind of the extrapolated version of where we're going to end up with this, or where they want to end up. And I know that you've been doing, I understand, a podcast about that and kind of really going in depth about what that entails. Can you talk to us a little bit about that?
Mars is a tricky equation. We see a lot of science fiction, and it's good storytelling, but it doesn't often educate us very much about the problems there. The situation on Mars is if we launch a mission there, it's going to take about 4 months to get there, and you're in a very enclosed, small place. And that places a lot of physical stress on people, but also psychological stress. You end up on this other planet, millions and millions of miles away, with no hope of rescue if anything goes wrong. You have to stay there for about 2 years and 2 months before the window is open for you to return, which is another 4 months. The whole time you're there for that almost 3 years, every 5 days, you're taking a full body CT scans worth of radiation. And so your chances of having cancer as a result of going on a mission like that are very high. The dust on Mars contains a compound called perchlorates, which if you breathe the dust goes into your body. It could be on your spacesuit. You come into your living center and the dust gets in and you breathe it. It destroys your thyroid. That's a bad thing. And so there's no water there, there's no air there, there's no food there. We have to bring everything with us, and you're isolated. And it's a tough go. And it's likely right now that if you go to Mars, you die.
How feasible do you think it is for this to actually happen, and what kind of timeline do you think that would take?
I think that by the 2030s, we could have someone go there on a mission. I don't think there's a problem with that. We have the technology, the SLS rocket, or maybe even the Starship would be able to get there. It's surviving it is pretty tricky, and we have to ask ourselves, why we're going there. If we want to go to a waterless, airless, bleak, rock-covered surface, we can go to the moon, and it's 2 days away. Venus is also a really great place. It's closer. We can't land on Venus. The surface temperature is 900 degrees Fahrenheit, but we can be in the upper atmosphere there. There is a project NASA has called HAVOC, which is a high altitude, almost like a dirigible, that you could float in the upper atmosphere of Venus, be protected from the sun's radiation. Temperature would be about 70 degrees. I could take your spacesuit off, the pressure would be fine. Draw chemistry from the atmosphere to have breathable oxygen, and it's closer. And the atmosphere would protect the astronauts from radiation. But you can't land and plant your flag there. And so it's not, the first choice. You want to go someplace and say that you are the first one to be on the surface. And the other thing is by going to Mars and we're there, we can look for the stuff that the rover's been trying to find and have human eyes on it. And the biggest thing we're looking for is examples of potential fossil life.
Do you think that's there?
It's quite possible. I don't know. We know that the conditions in the past on Mars favored the possibility of life. There was a large ocean that covered almost half of the planet of Mars at one time. And it's not there now, of course. Over geologic history, it's gone. But on our planet, if you're looking for life, you follow the water. And we've had life on our planet for between 3.9 and 4.1 billion years in some form or another. And that means that it's potentially early in Mars's history that it had life forms as well. Maybe just small single cell, but it still would have been life forms.
Well,
that means we're not alone.
That's exciting to think about, and just where the science is going with it, and sending more and more missions there, like you mentioned, eventually humans. Bringing it back here closer to home, I wanted to talk just a little bit about, you mentioned how much of a tie Oregon State University has, just with the space program in general, across the different companies and NASA, and maybe you can just kind of fill us in a little bit about this kind of rich history of that.
Yeah, Oregon State has a long history involved with space exploration. During the 1960s, after the moon missions were completed and they brought the rock samples back, a lot of those tests were done here at Oregon State because we were one of the few universities that had the equipment nationally that could test those rocks. We had neutron activation because we have a big nuclear reactor, electron microprobes, electron microscopes. We had all that stuff here. And for all that help, NASA sent some Doug fir pinecone seeds to the moon and back from the Klamath Nation. And they brought those back and they were planted. And we have a moon tree here on campus whose seeds went to the moon and back. And there is one also down in the Klamath Nations, down in Klamath Falls. And we also know that back in the 60s here in Oregon, that NASA came to Eastern Oregon and trained the astronauts in the high desert because they felt that the conditions, at least the visual conditions, were similar to what they were going to see on the surface of the moon. And here at the university, of course, we have an aerospace engineering program, which is very powerful, and the students are recruited heavily to SpaceX, NASA, Blue Origin, and of course, Oregon State is the home to the Oregon NASA Space Grant as well. And that's here to help undergraduate students have opportunities to go to internships with NASA, to have funded scholarships as well, and help them move into space exploration, astronomy, astrophysics.
That's really exciting that those opportunities are there.
It's an incredible program, and the director is really excited about what we can do and always have done for these students. And this is across all of Oregon. It's not just at Oregon State. It just happens to be housed here, but it covers undergraduate students across the entire state.
That's fantastic. Well, that's exciting, and I kind of want to bring it back here just to what was happening, today with this, and just get what were your initial thoughts when you watched this launch?
Oops. Yeah, I know they built it up a lot, and people were really anticipating it because of they had paused 2 or 3 times. They couldn't launch. And it's hopeful. We want to succeed. We want these engineering feats to be positive and to move space exploration forward. And when this happens, it's a learning experience. I mean, you're not going to throw it out. But yeah, it was kind of well, that's an oops moment.
Yep, it definitely was an oops moment. Yeah, I'll go from there. Doctor, I want to say thank you very much for joining us here to talk about this, and anything that you want to let people know too, just about that program at Oregon State, or where they can follow up with all the work that you're doing.
Oh, yes, I would go to the Oregon NASA Space Grant Consortium webpage. They also have a Facebook page and keeps you up on things that are happening. The physics department at OSU also has a web page that you can access. And I'll tell people to do this because they should be excited. We're going to have a total annular eclipse happen in October, and there will be lots of events happening across the state for that. And especially here at Oregon State, we'll be having all kinds of outreach events related to the upcoming October eclipse.
Well, Doctor, thank you very much. Appreciate it. I'll let you get back to doing all of your important work, and thanks for joining us here on Fox 12 Now.
It's my pleasure. Thanks for calling.
And
Bye.
for everybody tuning in too, we're going to take a break. We'll actually be back here in just a bit with John Horvick to talk about some data and some research that's going into where Oregonians are going, what they're thinking about. So that's coming up. So come right back here where